Welcome back, everybody. Ready for another deep dive?
Absolutely, always ready to dive in.
Today, we're tackling stream processing.
Yeah. Making sense of data that's constantly flowing, updating, changing all the time.
You know, it's like drinking from a fire hose, right? You're already drowning in it every day, though. I mean, think about it. Your news feeds, stock tickers.
Even those endless emails, yeah.
Don't remind me. But what if we could not just survive this data deluge, but actually use it to our advantage?
That's the real magic of stream processing, and that's what we're going to be unpacking today.
Exactly. And we're going to be pulling from some really great notes from a piece called Stream Processing with Apache Spark. Really interesting stuff.
Yeah, it's a great resource.
So we're going to uncover how companies are using stream processing to do some truly incredible things, like approving loans super fast, like in the blink of an eye.
You'll see how they recommend videos you actually want to watch.
Yeah, none of that, like random stuff,
And they can even predict when machines might fail before it even happens.
like Minority Report, but for machines? That's wild.
Yeah.
So to get started, let's break down some of the core concepts here.
Okay, so you know the difference between a static spreadsheet.
Yeah.
Okay, and like you're constantly updating social media feed.
Yeah, definitely.
That's the essence of bounded versus unbounded data.
Okay.
One is a snapshot in time, the other is constantly evolving. And that difference, that changes everything when it comes to how you process it, how you analyze it.
Yeah, I can imagine traditional methods wouldn't really cut it when the data's just nonstop. Yeah.
Right, exactly. With unbounded data, you need a different approach. You need stream processing. It's like you're analyzing a river as it flows,
Yeah.
not waiting for it to like pool into a lake.
Right. That's a really good analogy. I get it. But if this data is always on the move, how do you pinpoint time? I mean, things are constantly happening.
Well, that's where event time versus processing time comes in.
Oh.
Imagine a retailer using stream processing to track sales, like during a flash sale.
Oh, okay.
Each purchase has an event time, the moment it actually happened. But there might be network delays,
Yeah.
system hiccups. So the time your system actually processes that sale, it might be slightly later.
So if you're only looking at processing time, you're getting a delayed picture.
Exactly. And during a fast-paced event like that flash sale we talked about, that delay could mean you make bad decisions about inventory or pricing or even, missing out on some crucial trends.
Right, right.
Understanding that difference between event time and processing time, it's so important for accurate analysis.
Makes total sense. But thinking about all this data rushing in, doesn't that just make like resource allocation a nightmare? How do you predict how much computing power you need when you don't even know how much data is coming?
Yeah, you're hitting on one of the biggest challenges here, the uncertainty factor.
Yeah.
It's unlike that neatly packaged bounded data. Stream processing is like navigating a river with like changing currents.
Okay.
You can't always predict when a flash flood of data will hit or when things will flow to a trickle. So provisioning resources, the servers, the bandwidth, it's a real balancing act.
Yeah, I bet. Okay, so we've got the basics down, but what does all this look like in action? I mean, can you give us some real-world examples of how companies are using this to their advantage?
Absolutely. One area where stream processing just shines is device monitoring. Imagine your company's tracking its entire fleet of delivery vehicles in real time.
Oh, okay.
You'd have a constant pulse on location, their performance, and even potential maintenance needs, before anything even happens.
So instead of reacting to breakdowns, you could actually predict and prevent them.
Exactly.
Wow, that would be a game changer for logistics.
Huge. And it's not just about efficiency. Think about the implications for a company like Netflix.
Yeah, how do they know what I want to watch? I mean, it's crazy.
Right. They're analyzing your viewing habits in real time. They combine that with data from millions of other users. Then, bam, they can fine-tune those recommendations, keep you glued to their platform.
It's scary how well it works.
It is. That's stream processing in action, turning a flood of data into a truly personalized experience.
Okay, that's really impressive. And speaking of personalization, how is this playing out in other industries?
Think about loan approvals.
Okay.
Traditionally you would wait days, even weeks.
Yeah, it's painful.
But imagine a system that could analyze your credit score, your income, and transaction history all at once, real time.
So you could get a loan, like instantly.
Almost.
Wow, that would be incredible for small businesses. Anyone who needs quick access to capital.
It would completely streamline the process, make it faster and more efficient for everybody.
Yeah, that's huge.
And we're just scratching the surface here. I mean, we're seeing stream processing revolutionize everything from fraud detection to traffic management.
Okay, so it's clear that this can unlock a lot of potential, but we're talking about analyzing massive amounts of data here, nonstop. How do these systems even handle that without, like, completely crashing?
That's where something called MapReduce comes in. It's a model for distributed data processing. It's essential for handling these massive data sets.
Can you break that down for me a little bit?
Imagine you're baking 1,000 cakes.
1,000 cakes, okay.
Instead of one person trying to do everything, you'd have a team of bakers,
Okay, yeah,
each specializing in a specific task,
okay.
mixing batter, baking layers, the frosting. Then you combine their work into 1,000 perfect cakes.
So it's like dividing and conquering the data.
Yeah, exactly.
Each part handles a small piece, then it all comes together in the end.
Exactly. And this approach allows you to process massive data sets in parallel. So it speeds things up, makes the system more robust. Even if one baker goes down, the rest can keep working. And that brings us to a real superhero in the world of data processing, Apache Spark.
Apache Spark, I've heard the name, but I've never really understood what it is.
Spark is a powerful framework for handling big data. It's fast, reliable, incredibly versatile.
Oh.
It can handle both batch processing, like analyzing a fixed data set, and stream processing, where the data is continuously flowing.
Okay, wow.
Think of it as a Swiss Army knife for data analysis.
So it can handle those static snapshots and the ever-changing river of data.
Exactly.
Okay, that's impressive.
And what makes Spark so interesting for us today is its dedicated module for stream processing, Spark Streaming. It leverages Spark's power to handle that fire hose of data by breaking it into, like manageable sips. Little chunks processed really, really rapidly.
So it's like taking that overwhelming torrent of information and making it digestible.
Exactly. And then there's structured streaming.
Oh.
That's a newer addition to Spark.
Okay.
It takes an even more elegant approach. We'll dive into that next time. But first, what's standing out to you so far about the potential of all this?
Honestly, it's mind-blowing to think about the possibilities. We've talked about optimizing logistics, personalizing entertainment. I'm curious about the potential in other fields, like healthcare, for example. How could stream processing be applied there?
Ooh, great question. Well, imagine a future where, wearable devices are constantly monitoring your vital signs.
Okay.
Heart rate, blood pressure, even your sleep patterns. And all that data could be analyzed in real time.
Wow.
So it can alert your doctor to potential health issues
Oh.
before you even notice symptoms.
It's like having a personal health guardian.
Right.
Constantly watching over you. But what about something more immediate,
Right.
Like, could stream processing be used in, emergency situations?
Absolutely. Imagine a system that could analyze data from 911 calls, social media feeds, even traffic cameras, all to dynamically adjust ambulance routes, allocate resources, in real time.
Wow.
Could be the difference between life and death.
That's pretty incredible. It's amazing to think how all this could be used to make those really critical decisions faster, more efficiently. But you mentioned structured streaming earlier.
Yeah.
How is that different from Spark streaming? And why is it such a big deal?
Well, Spark streaming, remember, it's like taking sips from that data fire hose.
Yeah.
Processing those micro batches in rapid succession.
Okay.
It's powerful. But structured streaming, it takes it to another level.
Okay.
Imagine writing a single query, just one,
Uh-huh.
and it continuously updates as new data comes in.
So instead of thinking in batches, you're working with a constantly evolving view of the data.
Exactly, like a dashboard. It always shows the latest information, updating in real time.
Yeah.
This simplifies development, makes it easier to handle complex logic.
Okay, I'm starting to get why it's so exciting. Can you give me a concrete example? What makes it so powerful?
Okay, let's go back to that fraud detection example.
Okay.
With structured streaming, you could analyze millions of transactions
Whoa.
as they happen, looking for those suspicious patterns in real time.
Right.
And the best part is, you only need to write one query to define the logic.
Oh.
Structured streaming handles the rest. It just continuously updates the results.
So it's not just about speed, it's about elegance and simplicity.
Yeah, exactly. And it gets even better. Structured streaming integrates seamlessly with other Spark components. You can use Spark SQL to query that streaming data, or apply machine learning algorithms, even analyze those graph relationships, all within the same framework.
That's wild. It sounds almost too good to be true. Are there any drawbacks to structured streaming?
Well, Like any tool, it has its limitations.
Hmm.
For extremely low latency situations where you need a response like super fast in microseconds, you might need a specialized engine.
Okay.
But for most use cases, structured streaming just offers this amazing blend of power and simplicity.
Yeah, it sounds really impressive. So stream processing in general and structured streaming, they're pushing the boundaries of what's possible with data.
They really are.
But are these tools only for those big tech giants with
Yeah.
massive resources? What about smaller companies, or even individuals?
That's a great point. And the good news is that stream processing is becoming more accessible.
Oh,
Cloud platforms offer these managed services that handle all the infrastructure, makes it much easier for any organization to get started. And, of course, open source tools like Apache Spark are really lowering that barrier to entry.
so it's not just a playground for the big players anymore?
Not at all. We're seeing a democratization of stream processing.
Mhm.
More and more companies and people are recognizing the potential
Mm.
and they're finding really creative ways to use it. And as the technology gets, better and easier to use, I think we'll see an explosion of innovation across every sector.
Yeah, it's really encouraging. It sounds like we're right on the cusp of a data revolution.
Yeah, we are.
But but with all this power at our fingertips, we really have to think about the implications, Are there any potential downsides to this, all this real-time analysis?
Oh, yeah, that's an important question. Like with any powerful technology, there's a responsibility to use it ethically.
Mm.
We need to be mindful of privacy, data security, potential for bias in algorithms.
You're right. It's not just about the technology itself. It's about how we use it. We need to make sure that stream processing is used to create a more informed world, but an equitable one, a beneficial world for everyone.
Couldn't agree more. It's an exciting time to be working in this field.
It really is.
The potential is just enormous, but it's up to all of us to make sure it's used for good.
Well said. So, as we wrap up this part of our deep dive, what's the one key takeaway you want to leave our listeners with?
I think the biggest takeaway here is that stream processing, it's more than just a technical concept.
Right.
It's a fundamental shift in how we think about and interact with data.
Mm.
It's moving from reactive to proactive,
Right.
from like hindsight to foresight.
Yeah, it's not just about analyzing what happened. It's about understanding what's happening now
Right.
and using that knowledge to make decisions faster and better.
Exactly. And as the technology keeps getting better and more accessible, the possibilities are, they're pretty much endless. Imagine a world where businesses can personalize every interaction in real time,
Wow.
or doctors can predict and prevent health issues, cities can optimize traffic flow. Just so many possibilities.
It's mind-blowing to think about how many different parts of our lives this could impact. But for someone listen to this and they're thinking, okay, this sounds amazing, but where do I even begin? Like what advice would you give them?
I'd say just dive in.
Yeah.
There are so many great resources available online, tutorials, open source projects.
Yeah.
Apache Spark, for example,
Yeah.
they've got a great community, tons of documentation. It can help get you up and running.
So don't be intimidated by the tech side of things.
No,
Yeah.
not at all. The tools are getting easier to use all the time. And even if you're not a programmer, just understanding these concepts, it can be so valuable.
Right.
It can help you see the world differently. Data isn't just something we store and analyze after the fact.
Uh-huh.
It's alive. It's a stream that can inform decisions. It can help shape our future.
That's a great point. Shifting our mindset, data as a dynamic force.
Exactly. And it's happening all around us. Think about smart devices, the Internet of Things,
Hmm.
all that information. Stream processing is the key to making sense of it all, unlocking the insights hidden within that stream of data.
Absolutely. So if you're listening and you're feeling inspired, check out those resources we mentioned.
Yeah.
Explore Apache Spark, maybe try some tutorials. Who knows? You could be building the next groundbreaking application.
You could. And as you go on that journey, here's one last thought.
Uh-huh.
What if every decision we made, from the small to the huge, could be informed by real-time insights?
Mm-hmm.
What kind of world could we create where data empowers us to make smarter choices, to solve problems, to build a better future?
That's a powerful vision. It's a reminder that this is about so much more than technology. It's about unlocking human potential. It's about creating a world where data helps us do amazing things. And on that note, I think it's time to wrap up our deep dive into stream processing.
I agree.
I hope you enjoyed it. Until next time, keep exploring, keep learning, and keep diving deep.